I have two examples here, and what we're going to do is we're going to just get across the whole graphing or sketching of linear functions. It's only going to be a brief little summary. So I wanted to show you the example in the textbook, and they basically promote two methods for working out the sketch or the graph of a function. That's here on page 26. And it says, if you've got the y-intercept and the gradient, so it's in that form there, then you can sort of step from one point to the next point by considering what the gradient means. And I want to look at that, but I don't want to dwell on it because I find that methodology is really only useful when the intercepts don't matter and you're on graph paper so you can get it accurate. But apart from that, it's not so useful for sketching. And it says if the line is in general form, then you're going to do this method here, which is what I'm going to sort of settle on. So to show you the example, it says y equals minus a third x plus 2. And then what it does is it goes, well, the gradient is minus a third. And so it's treating the gradient as minus 1 over 3. So the y step, remember that gradient is rise over run. The y step is minus 1. So go down 1 unit. And then the gradient is 3, so go across 3, which is fine. You can also do things like go, it's not useful in this regard, but it's also true that the gradient is 1 over minus 3 as well. So I can go, I'm going to start here, I'm going to go up 1, and then I'm going to go back 3, and there's my next point, and then I can draw through. It'll give me the same line just further back, that's all. And then you can see this is the method here. Now, the reason why I don't necessarily like this method, although it's okay with graph paper, is that other than unevenness, normally when we sketch a graph, it's true for linear graphs, but it's very true for any graph we come across. What we want to do is we want to draw the line that represents the function, obviously, but we also want to highlight on our graph critical points. And critical points change depending on what the function is. For a linear graph, the critical points are the x and y intercept. Okay, so x and y are critical points, so therefore you should always graph them. So when I go over here, you'll see that my prep work is to work out the critical points. In the case of a linear function, the critical points are the x and y intercept. So for the y-intercept, and I always sort of start off with this because it then is exactly the same step even when we get to more complex ones. So the y-intercept is let x equal 0, and we're not going to muck about with it too much, therefore y is equal to 2. Because the x term disappears. And we know that's the y-intercept anyway. So I don't want to overblow it, but that's basically what's happening here. However, the y-intercept is not y equals 2. The y-intercept is 0, 2. Okay? If you write down, if someone says to you, what is the y-intercept? And you write down y equals 2, I think this is right. I don't think I'm talking it. It's not right. And I'm pretty sure that in the IB exam, you would not get a mark. That's a whole mark gone because you said y equals 2, because y equals 2 is not a coordinate. The y-intercept and x-intercept is a coordinate. Y equals 2 is an equation. 0, 2 is the coordinate. So make sure you're right. Get in the habit of writing coordinates. And even if the IB examiners don't take marks off, it's still bad practice to say y equals 2 is the x, or that 2 is the y-intercept. The x-intercept, it's okay to say it, like we're just saying it in summary. The y-intercept is 2, but you should always write it down as 0, 2. The x-intercept is when y equals 0. This is often when you need to do a little bit of working out. So I substitute 0 for y. Now I'm going to solve it. I'm going to subtract 2 from both sides. So subtract 2 to get minus 2 equals minus 1/3 x. And I'm going to multiply both sides, not just by 3, but by negative 3 to get x is equal to 6. That's 0. Sorry, that's 6, comma 0. Okay. What I'm going to get you to do now, I'm going to pause the video, but what I'm going to get you to do is see if you can work out the x and y intercept for part B, and then I'll come back and graph them. So let's see if you manage to sort of do what I do. It's really the same process though, right? It's a matter of going to work out the y-intercept and work out the x-intercept, and then going from there. So we go for the y-intercept, let x equal 0. So in this case, we probably do need to do a bit of working out. So we've got 2 times 0 is 0, so we've got minus 4y is equal to 12. So y is equal to 3. And over off to the side here, I put the point in, 0, comma 3. It's negative 3, isn't it? 0, comma negative 3. And for the x-intercept, we have let y equal 0. So we have 2x equals 12, and x is equal to 6. And so we have the point 6, comma 0. You okay with that? No dramas? Okay, so in terms of graphing, use a ruler, please, unlike me. Do as I do, not as I say. So you should have arrows at the end of your axes. You should label this with y and label this with x. Question? Nope, just heard some muttering. Put in your x and y intercepts. So for the first one, it is 0, 2. Label it, or even even better is to actually put the coordinate in 0, 2. And then we've got 6, 0. So don't stress too much about the again about getting it exactly right, but try and get it proportionally right. So I've kind of gone hopefully 3 times as long over here than I've gone up, sort of. And then I'm going to draw the line in. Now, I don't have my ruler with me, so I'm going to draw it in, and I'm probably going to miss everything. So excuse me while I do that, if I get it wrong. Yeah, that was pretty terrible. So don't do like me. Actually get it right. I'll try once more, but it's a bit hard. Normally I'd be getting my ruler and I'd be lining up the number, lining it up like so, and then I'd be right to go. So I'll just cheat and get rid of the 6, 0 and then put it on in again here. Okay, that's basically it. The other thing I would probably do, and I'm a little bit variable on this, is put arrows on the end of the line as well to show the reader that this line goes on forever. There's one of two things you can do. You either need to make sure the line goes for the whole length, the whole size of the Cartesian plane that you've drawn. So in other words, it should start up here and go all the way to here. And then it doesn't matter if you put arrows on or not. Or you could just draw it like I have and put arrows on. Probably pretty much the only thing that would be bad would be to do something like that. Where it's just a tiny little line. That's not good practice at all. Okay, and then I'll just do the other one really quickly. So I'll make them nice straight lines, at least for the axes. Arrows, x and y, and I'm going to have 0, negative 3 for the y coordinate, so that'll be down here somewhere. 0, negative 3, and 6, 0 will be here somewhere, and then straight line through. Oops. Close enough for the video. And where I'll put arrows on the end of it as well, just to finish it off. Done. And again, I can sort of look back at my equation and just confirm that it's looking about right. I've got a gradient of minus a third here. And yeah, that would make it fairly flat. It is fairly flat. And it's negative, which means it should be going downways, and it is. This one's a bit unclear what the gradient is without me rewriting it, so I can't quite tell, but it kind of feels like it should be about right. That's basically it. Any questions? Okay, so we've only got 5 minutes left. You are not going to get very far at all, but I want you to make a start at least. Well, you've got 5 minutes. I reckon you can possibly do it. Page 28. just question 6. I haven't gone through how to go from modeling an equation to solving it, but question 6 steps you through it fairly readily. So step through that problem, answer the questions as you go along. It'll give you a sense of graphing, or remind you how to graph, I hope.